Let's see, so you're all unmuted. I'm going to do the same thing I did before. I'm going to mute myself just to make sure there's no weird background noises. I'm going to put this in reading view, and it may take me a few seconds from when you say advance to actually have me advance. So I'm going to go ahead and mute myself now, and then whoever starts, just take it away.
All right. Hi, my name is Dakota Converso, and my partner is John Henry, and we're here today to talk to you about bottles hung to deter squirrels. Next slide, please. Okay, so the problem that we decided to solve. Squirrels take seeds and or nuts from bird feeders. Squirrels are getting into bird feeders, and our goal is to try and prevent that. So the solution also needs to be lightweight and effective. And these were some of the criteria that we decided to use earlier on in this project. And down below, we have an example of a squirrel breaking into a feeder. So next slide, please.
So for our solution, we decided to use a system of free spinning bottles suspended on lines between two poles. Basically, you would have a bottle with a hole drilled into the bottom end, and a rope would go through both ends of the bottle. And when a squirrel climbs on the top of the bottle, it will spin and the squirrel will fall off the bottom. And you put one of these bottles on each side, and you're able to hang any bird feeder you want and you like the look of. You might even already have one. You just hang that between the bottles, and it should prevent squirrels from getting onto it, at least somewhat. Next slide, please. We went through 3 major revisions to this one. We tried just 2-liter bottles, but squirrels seemingly they were still able to grab onto it. I think that because there's only one bottle, they were able to still get enough distance over the bottle to make it to the rope and grab on. We tried having 2 on each side of the feeder, but also you still run into the issue where the squirrels can get to between the bottles and then jump to the next one. And then the last solution that we tried was 4 2-liter bottles, but you cut the bottom off of one of the bottles and get the other bottom into it. By the time we had this solution, you have what's essentially just a long bottle. So when you have a squirrel climbing on top of it, they'll struggle to get all the way across and won't necessarily and might not go for that bird feeder, and they'll try and find something else. Next slide, please.
All right, so the market that we chose to try and advertise / sell this to, like what we'd ideally want, we chose homeowners. Homeowners have more freedom to DIY projects, and I would say this is a very DIY kind of thing. And they also have more spending money to maintain said feeders and buy such a product like this. They have more money than, say, like a college student or a young adult, usually. And squirrels live across most of North America, so our market is very diverse. We can sell to a lot of areas and get more sales. So next slide, please. So manufacturing. We decided the solution would be more fitting if it was DIY'd. So you can make it yourself, go to the hardware store, go get supplies very easily, like rope, metal rods, bottles such as that, things that you can get at the supermarket. But if it were to be like manufactured or mass produced, we would want it to come in like a simple assembly kit with instructions that you can use very easily to put it together at home. This benefits the buyer. It's easier to assemble. There's no need to buy certain parts. It's all in one nice, neat little package. And it would be cheaper to bundle all the materials and essentially buy them in bulk rather than buying them all individually. Next slide, please.
So in conclusion, we have this rotating bottle solution to prevent squirrels from getting into feeders. If you wanted to build your own, longer bottles work best because you want the whole thing to be spinning at the same time. And if you sell it in a DIY kit, you're able to sell cheaper. You don't have to actually do any manufacturing yourself. You can purchase individual parts, and you're able to sell it with a less finished design because the consumer would be expected to provide that themselves, and they'll be able to do things like paint it or customize it to their satisfaction. And our next slide is our is just our references. We have our two main references here. We have the tips for squirrel proofing and an article that sort of covers more of the same thing and the habits of squirrels.
So I have a question here. Did you actually, because when I first saw your slides, I'm like, did they actually, it sounds like you actually went out and put together something. Is that correct?
Yeah, I had something set up. I had some squirrel feeders, or not squirrel feeders, some bird feeders outside with the squirrel proofing. It wasn't going to be totally effective just because where I had to put it, it's surrounded by other bushes, so they can just jump in from the top.
Right. Now, did you see the squirrels actually try to navigate the obstacles and roll off at all, or?
I saw it happen once.
Oh, that must have been fun.
Most of the rest of the time, I've just seen a squirrel on top of the feeder, or
Oh.
they've been scavenging what birds have dropped.
Right. Okay. All right. So yeah, I thought, I'm like, oh, it sounds like they actually tried this and built it. And how long was the when you put the two bottles together? I'm assuming, well, maybe, what is that like? I don't know how tall, but how long is that?
About a foot, I guess.
Oh, okay. Oh, did you use 2-liter bottles or?
Yeah, 2-liter bottles just because they're bigger.
Oh, okay. Oh, I would have thought it was longer than a foot.
It might be a little longer than a foot. I didn't measure it.
Yeah. Huh. Okay. It's interesting.
Yeah, part of the reason we chose this problem was because we would potentially be able to create something that we would be able to solve, like at our own home feeders.
Right. I do like how you decided at some point, you're like, you know what? This might not be something we can actually sell. However, we could put that out as a do it yourself, or if you'd like to buy this simple assembly kit, which seems like it's going to be fairly low cost, right?
Right.
When you put it together.
Looking online, you can find 2-liter bottles for about $1 each when you buy them in a package of them. The ones that I saw were usually in packs of 6 or 12.
Empty.
Right.
Oh.
Because there are already kits and things for make your own soda and things, which people use 2-liter bottles for.
Good point.
So it seems like that's a lot more expensive than those bottles would actually cost, considering for about double that price you can fill it with soda and buy it. So
right.
I would assume that if you're building this kit, you could purchase those in bulk from the actual manufacturer and get them for maybe 10 cents each even.
Right.
So you'd be able to sell those and rope. You can probably even include the bird feeder, and it wouldn't be that expensive to manufacture, and you can sell it pretty cheap.
Right. Interestingly enough, bottles are actually shipped, like those plastic bottles you see, they're not actually in the bottle shape. They look like little test tubes. So they've been molded, injection molded already in the shape of basically the threaded top and the bottom part, which is like a test tube, looks like a test tube. And then at the actual bottling plant, they have a machine that blows it up. It holds it at the top, it heats up the plastic, and then it injects air, and it blows it up into a mold into the shape of the bottle. And then they fill it with soda. Because it's cheaper to ship thousands of those little small test tubes than to ship like thousands, they take up a lot less space than to actually ship like thousands of those big 2-liter bottles empty, right? You're shipping air basically. So just an interesting point of interest on that. All right, so that was interesting. Let me just make some notes here and then. All right. Well, I got most of the stuff down. I got your PowerPoints. Are there any questions from the audience? Oh, that's what I forgot. Any questions from the audience? All right, so I have,
I was just gonna say you could even put like logos and stuff in branding if you sold like a kit like that. So that
Yeah.
like if you wanted to take that idea and then expand it into like, oh, we just do like home, niche home, kits like that, you could have like a brand on like the bottle or something like that.
I'm gonna launch a poll like I did the last time you guys did presentations. Let me just make sure I've got the right one up here. Yeah, group 4. Yeah, because group 2 is on the list, but they're not here. So today's the even numbers. So go ahead and answer the questions in the poll as long as you were not a presenter. Let's see, 1, 2, yeah. And then just submit. You'll have to answer them all and then submit them all at once. And I'll get a screenshot of that. This is your class participation for the day. Well, if you're not presenting. All right, how many responses? Okay. Let me just everyone, let's see, 3. Oh yeah, I'm also in the meeting. I'm gonna end the polling, grab a screenshot. And save that. Oh man. All right. Let me end the poll. And then we'll start group. You guys are group 6, I believe. Oh yeah, I'm assuming you want me to run it as well?
Yes.
Okay. Let me minimize this. All right. So I'm gonna again mute myself and let's see, is everyone here? We've got Alex, Juliana, Justin, and Zach. I think you guys are all here. Yeah. All right. So I'm gonna mute myself and go ahead and start and let me know when to advance the slides.
All right, my name is Alex. My group decided to use a telescoping pole with a suction cup head to remove a light bulb that's far to reach, but my lab partners are Juliana Hansen, Justin Smith, and Zach Farrell. Next slide, please. So like I said, our problem is basically to replace a light bulb that's far out of reach. And for our product, we wanted it to be cost effective to the consumer, safe and easy to use because there are a lot of other products out there like this on the market. However, during our presentation, you will see and figure out why ours is superior to our competitors, and not only for the cost of materials, but for the simplicity of it overall. Next slide, please. So how it works is basically the suction cup can hold any size light bulb, virtually making our product, I want to say, universal to any light bulb scenario. And our product also has a safe release to lower the chances of breaking the bulb, because if the bulb's 6 feet up in the air from the top of your head and it breaks and it falls on your head and you're not wearing safety goggles or anything, you don't want a shard of glass getting in your eye. And so our telescoping pole is to reach far away light sockets, and the pole will include a quick release for the suction cup, and it will not allow more pressure than needed to be used. So like I said, our design is meant to securely and safely extract the light bulb so it doesn't like break or shatter or fall or get outside of that suction cup, so you can easily and effectively replace it and put a new one in. Next slide, please. And now Zach will talk about the prototype.
Good afternoon. So right here is a CAD file of our prototype of the pole. If you look at the bottom right picture, you can see the suction cup and the lever mechanism that pulls it tight to the light bulb. It's about 10 feet long. It has a 2-inch diameter, and it's going to be made out of injection molded plastic. It's a fairly simple design, and that's what's going to make it pretty cost effective. Next slide. For our cost analysis, the molds for plastic products can be very costly. So to keep them down, we're going to eliminate any type of special cosmetic features that, you know, would try to make it pop out more. It's just a utility tool. It's meant to work the way it is. We're not trying to make it all special looking. The simplicity of our latch that we have for the suction cup is what will help reduce the cost. And the most expensive thing for designing and developing this product would actually be the mold for it. Once you have that, then the injection of the plastic is pretty cheap, and you could buy the material in bulk to reduce your costs even more. We only need a couple molds for this product, just for the frame and the surrounding part for the suction cup and then the latch. And it's going to be fairly cheap to mold all of that stuff, and you can do a bunch of them very rapidly. Next slide.
Manufacturing our product will be easy to produce because of its simplistic nature. Our product does not demand any unique, extreme, or aesthetic resin characteristics, so we keep our production costs low. Our product's composition is generic in nature, so manufacturing requirements should stay simplistic as well. The basic manufacturing process should include injection and resin identification, product specifications, assembly, product coloration, packaging, and shipping. After we establish our mold and resin identification, the manufacturing process should be seamless, essentially. Our approximate cost is $4 to $5 per unit, and an including cost of $5,000 per mold. Next slide. In terms of market value, our product is viable because everyone uses some form of illumination daily. Due to that constant stress on lighting components and our relatable market, our product is profoundly marketable. We found a few competitors on Amazon, yet we feel our product is more marketable because our product accommodates a wider variety of bulb configurations. Overall, as a group, we feel comfortable with our product's marketable evaluation. Next slide.
So our target audience is elderly, disabled, and injured people who can't necessarily climb a ladder to change a light bulb or stand on a chair. It will allow them to do this task by themselves. Another target is warehouse and factories, because some sockets can be 15 feet from the ground, and they may have to use harnesses if they have to go 4 feet up. Next slide. There are a few competitors on the market. Most of them do include a metal prong or ring, but with our product it would be cheaper to make because of the suction cup. The only suction cup on the market.
Juliana, your microphone is, it's somehow, something changed. I can't hear you anymore.
Can you hear me?
Yeah, okay, it's better.
So there's a few competitors on the market. Most of them are metal prong or a metal ring design. And due to the only ones that are suction cup on the market, they can't fit multiple bulb types. So they sell attachments, which make them more expensive, like in the $30 range. That's the end.
You're on mute.
Yeah, I just noticed that. Just remembered. So let me go back here and make some comments because this is interesting. So the first thing is, when I first saw this, I thought this was is this a shield around the suction cup? Or this is the actual suction cup in two positions?
No, the inside one is the suction cup, and when you pull on the lever latch, it's gonna press up against that, and it's gonna allow it to keep a strong suction.
Oh, it's going to press up against this?
Yes.
So the suction cup's not actually suctioning the bulb then?
No, it is. It just uses that as like just to apply force on the other side of it.
Okay, I think I see.
If you look at any design online, similar for like the suction products, they all have that kind of design on them.
This looks like it would be to help release it because like the suction cup, all you'd have to do is press it against the bulb, right? And it would.
Well, we didn't want to do that because
because the breakage.
If you press it, you can break it. So you basically just place it against it, and then you pull, and the force acting on it from the outside shell is going to help create that suction.
Okay. Yeah, I think this might be problematic to try to fit flatter bulbs just because I don't see how this is going to expand out. Like the rubber part itself has to expand. So this is interesting. This is an example of you weren't able to actually build a prototype and test it. So you did it in CAD. You came up with an idea. It would be interesting to see, right, if you did build this thing, like even if you just built this section up here with a little lever in the back that you can pull and stuff, to see how well this works, right? What range of bulbs it can accommodate. You know, if the mechanism works well with just certain type of bulbs and not others, right? Because I would imagine this would work better for like a rounder bulb than a flatter bulb where you'd have to spread out the suction cup a little more. Anyway, the other comment, and then again, this is not, these comments are just sort of, you know, first pass on looking at this. You know, I'm not expecting you here that you came up with a perfect design or that you know, all your manufacturing techniques are on. It's obviously, excuse me, you're still learning a lot about things. And part of this project was this, or the primary purpose of this project was to get you to thinking along the lines of, okay, if I'm doing some kind of design work, if I'm trying to solve a problem, right? How would I go about doing that? What are the steps and procedures involved in that? And this is just one of them, right? If you went to, where'd you get the price for the mold? The estimate. The mold of the, you said you were going to injection mold this thing?
I believe Justin found it.
I don't have it in front of me currently, but I have it on the final assignment. I attached it.
Oh, okay, and this is the,
as a portion of the cited material.
all right, this is the mold for the tube.
It's an approximate value of generic molds.
Okay, but I mean, the idea is that you're injection molding the tube or the components around it.
The entire product.
Oh, okay. Because here's my suggestion as someone who's done some polymers work in the past, you probably wouldn't actually injection mold the tube. You'd have the tube either some kind of off-the-shelf component or extruded. Well, I mean, it would generally be extruded. So something like, typically, like if you go to the hardware store and look at a PVC pipe, it's not injection molded. You typically have those extruded, and you can tell because the length along the, do I have a PVC pipe here? I used to. The length of the pipe, there's no seam. Injection molding has a mold with two parts that come together, and then they come apart. And typically where the mold comes together, there's usually some kind of seam. And so it's very easy to tell injection molded objects because of things like a sprue and a seam. So let me show you something here. This is a little cup that I have on my desk to put pistachios in. It's actually the top from a like an old baby bottle, I think. And this is a old, what is it called? One of these old medicine bottles.
Bottle.
What's that?
Pill bottle.
Yeah, pill bottle. So let me zoom in a tad here. You see this little, this is just, you know, I've always loved polymer stuff. I'm going to show you this little spot in the middle there. That little dot.
Yeah.
That's called the sprue. Well, it's actually left over from the sprue. There's also a little dot in the middle of that one. And the way this mold is made is in this particular one, it's probably a two-part mold like this, where it opens up and like it's got an inner part and an outer part, and it pops it out. But the injection happens from the end where the sprue is. The sprue is where the molten polymer comes in, the liquid polymer, and it fills the mold. And what's interesting about injection molding is you typically try to mold, you inject with the lower cross section. So the cross-sectional area of this, you wouldn't want to inject from the side. Oops, my camera froze. Come on, let's restart. There it is. You wouldn't want to inject from the side because it takes a lot more pressure to distribute that polymer out like that through a cross-sectional area this width. This is basically, looking at this, it's like a rectangle. Then to distribute it along a circle. So here you have to distribute it out and down. So that's what they do. They typically do an injection mold like that. I wish I had more plastic pieces. But anyway, for a tube like that, you'd probably have an extrusion die, which would be fitted on the end of. So you'd have a die which has a certain inner dimension and outer dimension, and it would be fitted on the end of a extrusion machine, and it would start extruding the polymer, and then as it came out, it would cool and harden. It would probably be oriented vertically so that the polymer would stay straight, the tube would stay straight, and then after a certain amount of length, some machine would come and chop it off, and then you could probably machine in this, you know, just really quickly automate some machining tool to basically cut out this hole and put some hole in for the pin that holds this lever. And then the end cap is probably something you would injection mold. So you could have like one mold that had both the lever and the end cap in it and this piece, right, all in one mold. And you could injection mold those all in one shot, so 3 pieces at a time. Just again, depending on the cost of the mold, you might do 1 piece at a time. But if you're going to make a mold, a lot of times the cost is a fixed cost to making the mold. These molds are very, very smooth and polished, and they're made out of typically, you know, like a stainless steel or other type of very corrosion resistant material, and they're also like water cooled. So there's some decent amount of engineering behind these molds. So it's really a fascinating process. If any of you ever get a chance to you know, see any type of polymer, of course most of that's in other countries now, but it's really fascinating the way different plastic components are made. So that was my only comment about plastics. I thought I'd just, you know, share some of that. Let me launch a poll here. Are there any questions from the class? Oops, wait a minute. On this presentation. So I just launched the poll. Anyone from the class have any comments or questions? But yeah, I like the idea. I mean, it looks like you definitely looked at some other prototypes online and said, okay, these are competitive products. And that's what you want to do, right? When you're designing new products, you want to see what's out there. What have people already done? What can we learn from that? And ideally, in a real product development standpoint, you would go ahead and you'd see, okay, what type of patents are on these products, right? Do they have patent protection? And that's going to limit maybe what you can do that looks similar, right? But then you came up with this new idea, which is to have this cone, this rigid cone behind your suction cup, right? Is this patentable, right? This may be something you may be generating IP. And then there's rules around, okay, when you actually make some new product, before you start selling it, right, you need to file this with the patent office to make sure you have you file it before it becomes public, right?
Would it just be like a design patent?
No. Well, yeah. Well, let's see. Design. No, this would be a utility patent. A design patent is more for. I've never actually worked on a design patent, but they're more for like artists and architects and things like that. It's like patents that. Well, I mean, you could have a design patent on a product. It's more for a.
So the use of the product then is utility?
Yeah, utility. So I mean, that sort of makes sense. Design is more of how it looks, right? It's more of an artistic type patent, if you will. I'm not an expert in design patents. I really probably am not explaining this well at all. But a utility patent is, yeah, a patent that covers the use of, this is a new design that can be specifically used. That it provides a new utility, right? Or provides a utility, and it's a new design to do that. So you'd file something like that. Now, have you ever seen products where they say, "Oh, patent pending," right? Well, there's two ways in the US to do this. You can file what's called a, oh geez, I don't even remember the name, it's escaping me. A provisional patent. And a provisional patent gives you a year in the US to work on and refine that product. So you may be in a hurry to get something out there, and you're like, well, you know what, we want to do a little more research work around this and make sure we cover more, more options. We're going to put a provisional patent out there that covers this. And then the provisional patent acts as sort of a placeholder for you. So the patent office has this provisional patent, which, may be very, very generic, covers a lot of things. And then within that year, you now have time to refine it and make a write up a very good patent and submit that to the patent office. They don't actually evaluate the provisional patent for anything. Provisional patent is basically used as a date. Like if you want to start selling something, right, you got to get something to the patent office. The provisional patent allows you to do that. So you can start selling this thing. And in the meantime, finish up your actual patent, which you then send to the patent office. And that's the one that they actually examine and look at. And the patent examiner is looking for things like, is this really novel, right? Has this ever been done before? They'll look for prior art. And prior art could be anything. It can be a magazine article from France. It can be, it could be a sketch on the back of a napkin from, that someone's posted on Facebook these days. So you can see how finding prior art can quickly become an astronomical task these days. Well, it's actually somewhat easier now because you can actually find things with searches electronically. And then they're also looking to see, all right, is this really something that's not obvious to someone skilled in the art? And this is the subject of a lot of controversy with patents, right? What does that mean? not obvious to someone skilled in the art. So let me just capture this poll here. So basically it's saying if I were a mechanical engineer and I'm putting in a patent that involves something that most mechanical engineers would know, right? How do I go about showing, or if I'm educated in the field, right? This patent is not obvious to me, right? It's not an obvious idea. It's some idea that I would have had to really do a lot of work to figure out, right? And so not obvious is really kind of a hard criteria, I guess, to prove or disprove in court. And a lot of patent litigation revolves around that that concept of, oh, well, this would be obvious to someone skilled in the art. And lawyers will bring in expert witnesses and to show, you know, this is not an obvious thing, or this is an obvious thing, depending on which side you're on. All right, so I talked a lot about patents and plastics there. Any other questions? Let me do a quick overview. I'll post this, but I thought it'd be useful if I talked about it a little bit. Let me end this PowerPoint. All right, I had I'll get the examples out. All right, so I said I was going to do a quiz next week, and it'll probably post on, like, I don't know, I suppose I could make a post Sunday. Oh, also I have to post an announcement. One of my colleagues from Praxair is coming in next Wednesday. So what is that, the 16th? He's going to Zoom in. Yeah, the 16th. So remember, I had you guys fill out and ask some questions about what you'd like to hear about. He wasn't sure if he could make it Monday or Wednesday. He's coming in Wednesday. So Wednesday, the assignment is come to class. I'm going to grade you on come into class. I'll make that an assignment in Blackboard. And then you can take the quiz. Maybe I'll open it up Sunday, Monday, Tuesday. But anyway, the quiz, this is not the quiz. These are the in-class examples. To make the quiz, I basically went through the notes and I said, okay, first of all, before you even look at this, number one, you got to know forces, velocities, those are vector quantities, right? They have both magnitude and direction, right? So this is a force. It has a magnitude of 10 newtons and it has a direction. Force and velocity are vector quantities. They have force and direction, or magnitude and direction. And then I also have a question asking you what the units of force are. This is all multiple choice, so you'll have questions and then answers that you can choose from. Now, then I said, okay, I'm going to go through the examples I gave in class, and the perfect way to study is basically take the in-class examples, download the sheet, and go through the problems, see if you can do them on your own. There will be something like this, where you have to choose the proper trigonometric function for the force, right? I'm going to give you a force. Remember those questions I did the other day where I had a PowerPoint up and it had an arrow pointed in a certain direction, and then it had an angle, right? 30 degrees. This is really, wow, this is bad. So if I gave you a force and an angle, you could tell me the X and Y components, right? I'll have you choose from 4 or 5 different choices of, force sine 30 or force cosine 30, or be careful of signs, right? Watch the direction of the force. Oh, there'll be a problem like this. It'll tell you, there will be no diagram. It'll tell you a force of whatever acts at some angle from some axis, and you'll have to find the X and Y components. vector notation, this notation, right? I'll ask you to select the correct notation for a given position vector. So I'll give you a position vector. There'll be a grid. You'll have to figure out, okay, the X and the Y, right? Like this is 1, 2, 3, 4, 5 I plus 3J. You have to figure that out. There's another problem, which is, see, I've got the quiz right in front of me here. Position vector, oh yeah. Find the position vector of B with respect to A. So I'll give you 2 points. I'll show you the position vector, and you need to find out the position vector between the points. Be careful of direction, right? A position vector in this case are B with respect to A, RAB. That's the B coordinates minus the A coordinates, right? The position vector is B minus A. It's not A minus B. So be careful coordinate wise. Let's see, there's another one that is similar to this. I'll tell you a vector has a certain magnitude and a certain direction. Be careful, right? Counterclockwise from X or clockwise from X. Those are 2 different directions, right? And I'll have you calculate the, give me the correct vector notation, right? So you'll have to choose something like this. So you'll have to go through the process of figuring out the vector. Again, if you just download these example problems from Mod 3, I'll show you that when I go through. Let's see, what else? Position vector. Oh, wow, it's not that long at all. There's a few more. There's a hiker. Oh, yeah, there's a hiker example. There's actually a hiker that walks different directions than this. So I'll tell you like southwest or northeast, right? And I'll give you an angle off of one of the axes. So if I told you a hiker went northeast 60 degrees off of north, right? It would look like this. It would be 60 degrees off of north, 60 degrees off of north, northeast, right? If I told you southeast, right? 30 degrees off south, that would be an angle or a vector like this, 30 degrees off of south, right? So just read carefully and write things down, draw yourself sketches. You can write whatever you want. I'm not collecting your work. You're going to have to just choose the right answer here. And I'll ask you for the resultant displacement and direction from the starting point. Let's see. There will be a vector. Let's see. You'll have to do something like this. Come on, where's this? Oh yeah, example 10. There will be an example with 3 vectors. Know how to get the vector components, because there's 2 problems. One problem is getting the vector components, knowing just the dimensions, right? So I'll give you one vector and dimensions, and you got to figure out what the X and Y components are. That's using the ratio of the lengths. You could solve it using an angle too. I don't actually care. And then the next one is going to be, you'll have 3 vectors. You'll have to do the X and Y components of those vectors, right? Like we did here, add them up, find the resultant, and then find the direction. So again, go to your example problems, which are located in module 3. So let's go there. Learning module 3, vector concepts. If I were you to study, the best thing you can do to study for this quiz is to download this one, example vectors, print it out and go through all the problems. And then look at the answer key. Don't look at the answer key first, go through the problems first, then go through the answer. I mean, we already did them once in class, but if you can do them on your own by yourself without any help, right? It means you've learned something. And if you struggle, right, move on to the next problem. Don't look at the answer key until you've done as much as you can on your own. And then look at the answer key. I will make a formula sheet up that will have Pythagorean theorem, law of cosine, and law of sine. I have to look through the quiz to make sure there's nothing else I'm missing that I'll need to upload for this. But yeah, that's going to be the quiz, and I'll put that so it posts probably on Sunday. Any questions about anything?